Hi everyone, welcome back to the channel, and today we're going to solve Leetcode daily challenge problem number 997. Find the town judge. So it is a really easy problem, and we'll first check out the problem statement, then we'll look into the approach which you're going to use, and towards the end we'll see the code as well. So starting with the problem statement, it is given that in a town there are n people labeled from 1 to n. Okay, 1 to n. There is a rumor that one of these people is secretly the town judge. If the town judge exists, then the town judge trusts nobody. Okay, everybody except for the town judge trusts the town judge. Okay, there is exactly one person that satisfies properties 1 and 2. Okay, so basically, if the judge is there in the town, then he don't trust anybody, and everybody trusts that town judge except himself, and there will be only one such person if there is uh, among the population. We will get an array trust where trust of I is A of I comma B of I, representing that person labeled I trust the person labeled B1. So basically A trust B. Okay, if a trust relation does not exist in trust array, then such a trust relation does not exist. So basically, if the entry is not there about the trust of person X to Y, then they don't trust each other. So return the label of the town judge if the judge exists and can be identified, or return the minus, or return -1 otherwise. So basically, if the judge is there, we'll have to return the label of him, for example 1 2 3, whatever it is. Otherwise we want to return -1. So to solve this question, there are multiple ways to solve this question. You can use a hash map, and there is a graph approach which I'll be discussing today, which I found very interesting. So this is the approach which we'll be using to solve this question. So first I will go through what we have done over here, and towards then we'll see what is the crux of it. So basically I have used two examples from the question itself. First one is n equals to 3, and this is the trust array. 1 trust on 3, 2 trust on 3. Okay, so if you plot the graph, it will look something like this. Okay, so all these are edges and these are the vertices. Oh, the other way, sorry, these are the nodes and these are the edges. So 1 trusts 3, 2 trusts 3. Now if you draw the inbound and outbound edges on each vertex, what will you see? That on one, number of inbound edges is 0, because there is no incoming arrow in it. Okay, but there is one outbound edge. Similarly for 2 as well, there is no incoming edge, there is an outbound. But for 3 there are 2 incoming edges and there is 0 outbound. Okay, and similarly the other example, we have n equals to 3, and this is the relation, what is described in this array. And if you plot this, what you will see, that there is one inbound and one outbound on 1 and 0 on 2, and the third node has 1 inbound and 2 outbounds. Okay, one in yeah, sorry, my bad, it should have been the other way around. So he has 2 inbounds and 1 outbound. Okay, so now if you see, the crux of this situation is, like, if you remember the condition, judge trust nobody. Okay, and everybody trusts judge. So if you basically just subtract out your outbound edges from your inbound edge, inbound minus outbound. Okay, and if you get number of people -1, number of people -1, then this will mean that the person who satisfies this condition is a judge. Why? Because inbound basically represents uh, he has trust, he has trust, and outbound represent he trusts. Okay, so of course, if we'll do inbound minus outbound, we, or if you just simply say, Yeah, I think this will have to do. He If he has everyone's trust, of course this value will be number of people minus the judge himself, minus judge. Okay, and outbound is 0 obviously. Okay, because he does not trust anybody. So if this condition gets true, then we get the judge. For example, in this case, this particular value or this particular person satisfies the condition, therefore answer is 3 only. Okay, but in this example there is no such person who satisfies this condition. For example, if you see this, it is 2 minus 1, which is 1. It is not equals to 3 minus 1, right? And there is no such no other person as well. That's why the answer of this example will be minus 1. Let's check out the code for the same. It will be a very simple code. So what we are doing over here is I am using an array, okay, and I have initialized it with 0. So this basically means every index, the value at every index shows the uh, number of people who trust on him. Okay, next what I'm doing, I am just simply iterating the trust array which we have, and we'll get two values, right, a and b. So a basically trusts somebody. In that case, I am subtracting minus 1 from it. Okay, and b, like, b is the node who is getting the trust of a, so that's why we are adding 1 in it. Next is I am running a loop from I to n plus 1. So this, like, it will be running from 1 to n, because last number is obviously not included in the range function. And if we satisfy this condition which we just talked about, temp of I equals to n minus 1, then we will simply return the label of the judge. Otherwise, like, if we don't find any person who satisfies this condition, we will be returning minus 1. Let's check out the test cases. So as you can see, the test cases got cleared. Let's submit it for further evaluation. Okay. Yeah, so as you can see, like, we have performed very well. We have outperformed around 97.50% of the submitted solutions. So yeah, this was the solution, guys. Thanks a ton for watching out the video. Stay tuned to the upcoming ones. Don't forget to like the video and subscribe to the channel. Thank you.